is DB, and today we're going to learn about how to solve rational equations, and we'll also look a little bit at inequalities, although most of that we'll do in another video. So this is from Chapter 8, Section 5 of your textbooks. A rational equation is an equation that contains one or more rational expressions. A rational expression is a fraction that has a variable in the denominator. The time t in hours that it makes to travel d miles can be determined by using this equation, t equals distance divided by rate, where r is the average rate of speed. That's an example of a rational equation because there's a variable in the denominator. So what we're going to do is start by multiplying each term of the equation by the least common denominator. What this does is it eliminates all the denominators in the rational expression, and then it results in an equation that you can solve by using the same algebra that you've used before. However, when we do this, we have to consider that there is values that x cannot be equal to because it's in the denominator and we cannot have the denominator equal 0. So right off the bat, I'm going to say to myself, x cannot equal 0. If I were to end up getting 0 for an answer, I would have to say no solution. It happens once in a while. So the first thing we do is we figure out what is the least common denominator of all of these fractions. If there is no denominator, it's a 1. So 1, x, and 1, the least common denominator is just x. So all you're going to do is multiply both sides of the equation by that number, or variable in this case, x. So we have x times x, distributive property, minus 18 over x times x equals 3x. And then we simplify. These x's cancel, so I won't have x in the denominator. X times x is x squared. So we have x squared minus 18 equals 3x. Now you can set this equal to 0 and see if it'll factor. The factors of negative 18 are 9 and 2. 1 needs to be negative. That's not going to work. 6 and 3, and 1 needs to be negative. If I use these factors, when I add them together, I would get negative 3, which is the middle term, coefficient of the middle term. So I factor this to x minus 6, x plus 3, and now I can set each of these little equations equal to 0. So if x minus 6 times x plus 3 equals 0, that means either x minus 6 equals 0 or x plus 3 equals 0. So either x equals 6 or x equals negative 3. And then remember that x cannot be 0. I didn't get 0 for an answer, so both of these numbers should be good. You can check them by just plugging each of those values back in and making sure that you get a true statement. So when x is 6, we get 3 equals 3. That's good. When x is negative 3, I would get negative 3 plus 6. That's also equal to 3. So both of my answers work. So there's 2 answers for that problem. Okay, here's one from your worksheet. We have 10 over 3 equals 4 over x plus 2. So our common denominator is of 3, x, and 1. So our common denominator will be 3x. So we're going to start by multiplying both sides by the common denominator of 3x. When we do that, 10 over 3 times 3x, the 3's cancel, and I'm left with 10x. Here, the x's would cancel, and I'll be left with 4 times 3 or 12. And on the last one, nothing will cancel, and I'll have 6x. So 10x equals 12 plus 6x. Nothing squared here, so you won't have to factor. Subtracts, oh, I forgot to say what x can't be. So I have to keep in mind that x cannot be 0 because then the denominator will be 0. So I divide both sides by 4. X equals 3. And then you just check it and make sure that it works. So if I put 3 right here, I'd have, whoops, I'm trying to check it. I would have 10 thirds. Does that equal 4 over 3 plus 2? Well, another way of writing 2 would be 6 thirds. So 4 thirds plus 6 thirds is 10 thirds. So it does check, it did work. All right, here's another one from your worksheet. First step is to find out what is the common denominator. This time they have a denominator for each of them, x, 4, and 4. A common denominator would need the x and it would need just one of the 4's. So the common denominator is 4x. So we have to multiply everything on both sides by 4x. And then we cancel what we can. X's would cancel, and we'd have 6 times 4. 4's would cancel, we'll have 5 times x. On this side, the 4's cancel, I'll have negative 7 times x. So that all simplifies to 24 plus 5x equals negative 7x. And again, x cannot equal 0. And then we solve by subtracting 5x from both sides. So 24 equals negative 12x, and then divide by negative 12, and we'll get that x is equal to negative 2. We can check that by putting it back in. It's only one spot. So we'd have negative 3. 6 divided by negative 2 would be negative 3 plus 5/4, and I want to see if that equals negative 7/4. So if I change negative 3 to fourths, I'd have negative 12/4. And negative 12 plus 5 is negative 7/4, so it checks. One more from your worksheet. This one will get something squared because the common denominator is x. And when I multiply both sides by x, I'm going to get an x squared over here. So we'll have x times x equals 6 over x times x, those will cancel, minus 1 times x. So x squared equals 6 minus x. When you see something squared, the first step you want to do is set it equal to 0 and then see if you can factor it. So we'd have x squared plus x minus 6, and then you set up your factor parentheses, and you think to yourself, I put your x here and your x here, and then you look at the negative 6 and you think, what are the factors of negative 6 so that I'll get a 1, positive 1 when I add them. So 6 and 1 isn't going to work, but 2 and 3, one of these will work. If I use a negative 2 plus 3, I would get a plus 1. If I had the negative on the 3, I'd get negative 1, which I don't want. So I can do x minus 2, x plus 3 for my factors. Where did my pen go? I was going to erase that. And then you just set those two little equations equal to 0, and then you'll find your answer for the problem. I forgot to say what x can't equal here, but it would be 0 again, because that would give you 0 in the denominator. So x will equal 2 or negative 3, and then check them and make sure they work. So if you put 2 in, you would get 2 equals 6 over 2 minus 1. 6 over 2 is 3 minus 1. Yep, 2 equals 2. If I put negative 3 in, I would get negative 3 equals 6 over negative 3 minus 1. So that'd be negative 3 equals 6 over negative 3 is negative 2. And that's also going to work. So it works for both of my answers, so I know that these are my two solutions to this problem. All right, so an extraneous solution is when you solve this and you get an answer that does not work. And it is possible to get these, so that's why you should always check, as I was showing you how to do. So here's an example where we might get an answer that doesn't work. So in this one, our common denominator is x minus 2. So I'm going to multiply both sides by x minus 2. And also I should note that I cannot get 2 for an answer. If I get an answer of 2, then that would give me 0 in the denominator, and that wouldn't work. So when I multiply both sides by x minus 2, a lot gets canceled here, and we're just left with 5x equals 3x plus 4. So when something like that happens, it's something to note that, wow, I changed my answer a lot by dividing or by multiplying both sides by the common denominator. Now we get this little answer, and it's x equals 2. But we just said that x cannot equal 2, because if we do, we'd get 0 in the denominator. So therefore, when you end up with something like that, you have to say that there's no solution. There is no number for x that will work to make this fraction equal to this fraction. And they're just checking to show that you're going to get 0 in the denominator, which is not allowed, so it doesn't work. Okay, here's another example. Note right away that x cannot equal 8, because if we did, we would get 0 in the denominator. Our common denominator of this one's a little trickier. We have an x minus 8. We also have a 2. So the common denominator is 2 times x minus 8. 2 times x minus 8. So when I multiply both sides by 2 times x minus 8, in the first one the x minus 8's cancel, in the second one the 2's cancel, in the third one the x minus 8's cancel. So I'm left with 2 times 2x minus 5 plus x times x minus 8 equals 11 times 2. Alright, so then you distribute the 2 through and the x through and multiply the 2 times 11. And we get 4x minus 10 plus x squared minus 8x equals 22. We're going to continue this on the next page because that's a little bit too much to fit. Then we combine our like terms and write it in. So we had a 4x minus 8x, so that's negative 4x. And then we set it equal to 0 and write it in descending order, and then we attempt to factor this. So negative 32, I need the factors of that, which I think these are I think I picked the right ones right away. So x minus 8 times x plus 4, and then that means we have two answers, either x equals 8 or x equals negative 4. But if we remember, at the beginning we said x cannot be 8. So we will get one answer. We can use the x equals negative 4, but the other one we say is an extraneous solution because it would make the denominator 0. So then we just check this one answer and make sure that that will work. And then they're checking it. They're checking it a little different than I would, but you can check it and you'll see that negative 4 does work when you plug it back in, and it's a solution. And there's only one solution. So part of your worksheet is you're going to name what values of x would be extraneous solutions. You don't actually have to solve these equations. You just have to say what x cannot be equal to. Like number 4 is already done, x could not be 2 because then you'd get 0 in the denominator. When you have something like 9, the easiest way to find what would make this 0 is to just go ahead and set it equal to 0 and solve, and you'll get a fraction for this one. 3, that's a negative there. So 9, you cannot let x be negative 2/3 because then you would have 0 in the denominator. For some of them you'll have two answers, like in number 7, you might even have 3 answers for number 7. And in number 8, you'll have 2 because you'll take this equal to 0 and this equal to 0. And you'll get 2 different values that would make that be 0 in the denominator, which is not allowed. I'm just going to talk a little bit about the rational inequalities part. There's another video that shows how to do the problems from your worksheet, but just wanted to explain a little bit about what they are. It's an inequality that contains one or more rational expressions. So it's going to have a less than or greater than sign, or less than an equal or greater than an equal. You can solve these with graphs, and in the other video I show how to use desmos.com nice graph to do this. But here's how it would look if you used a graphing calculator. So here's x over x minus 6 is less than or equal to 3. If we were to graph the left side and then graph the right side, we could see when does this expression, it's not a function, this relation, when is that less than the horizontal line of y equals 3? That's what we're going to be looking for. Maybe it is a function. So here we have this hyperbola here, the curved lines, is x over x minus 6, rational function. And I also graphed on here there's an asymptote there at 6, x equals 6, because it will never touch that line. And then also graphed on this screen of a graphing calculator is the line y equals 3, which is a horizontal line right there. And what we want to know is, when will this be less than this line? So if I were to graph everything less than that, it's in the purple region here. And in the purple region, when x, let's see, right here they say that this point is 9, 3. So this is right here is 9, and this right here is our asymptote. So we can't let x be 6, but we can let x be less than 6. That would cover all of this part of the graph. And if I let x be greater than or equal to 9, that covers all of this part. Note that it's just less than 6 because it can never be equal to 6 because 6 is an asymptote. It can be equal to 9 because that's a point right on the graph. We also have to then, well, we don't have to, but we could look at a table and we'll find that there's certain places where the first one will be less than the second one we graphed. So here it's less than, that's good. This is equal, this is greater than, here it's less than. So the starred regions are where it works, and the other regions is where it doesn't work. So that verifies what we found from our graph. So what you would write for an answer is x is less than 6, or x is greater than or equal to 9. That is what you would write for a solution to this inequality. We can also solve these algebraically. So if you're solving these on, this is the second part of the worksheet, you can check this with algebra and with the graph, and you can make sure you get the same thing. So what we get, though, is that either this denominator could be positive or it could be negative. We don't know yet because we don't know what x is. If it's negative, when you multiply both sides of an inequality by a negative number, you switch the inequality around. Probably remember that. So we have to look at two different cases. So case one is, let's just assume that x minus 8 is positive. So we go ahead and solve the same way we would if it was an equation. We multiply both sides by the least common denominator. And let's see, this would cancel, and you'd get 6 is less than or equal to 3x minus 24. And then we finish solving that to find x at 24. So 30, and then we divide by 3. So we get 10 is less than or equal to x, or x is greater than or equal to 10 if you prefer. Now that's also note that x cannot be equal to 8. But that's okay because we said it was going to be greater than or equal to 10. That's for our positive case. And we also have to consider that that means that x minus 8 has to be greater than 0 because it was positive. So if we add 8 to both sides, x has to be greater than 8, and it has to be greater than or equal to 10. We need to pick the one that covers both of those situations, which is this. X is greater than 8 is well and good, but that didn't satisfy the other part, which is that x also has to be greater than or equal to 10. So we just need this part, the x is greater than or equal to 10. All right, now let's consider what if the denominator is negative. So we would still multiply both sides by x minus 8, but this time we would have to switch the less than sign to a greater than sign. So we switch this to this, because when you multiply by a negative, it changes that. And then we would have 6 is greater than or equal to 3x minus 24, and then we solve the same way. So we get 30 is greater than or equal to 3x, divide by 3, and we get 10 is greater than or equal to x, or x is less than or equal to 10. But we also have to remember that that means that x minus 8 is less than 0, so let's see what we get. We add 8, and so we have to have x is less than or equal to 10, and x is less than 8. Well, x can be less than or equal to 10, but not less than 8, like 9. That doesn't cover both situations. So we need to go with this one, which would cover both cases. So we now know that x is less than 8. That's our second part. And we already had that x was going to be greater than or equal to 10. So this is only going to work when x is less than 8 and or x is greater than or equal to 10. So there's only going to be certain places where this inequality will hold true. Less than 8 or less or greater than or equal to 10. This is just another example using the same method. When we have a positive least common denominator, you just multiply both sides, simplify, find the value of x. In this one, we would get x is greater than or equal to 1/2. But also, we have to consider that that means that x minus 2 has to be greater than or equal to 0. So x has to be greater than or equal to 2 and greater than or equal to 1/2. Well, that means we're just going to use the greater than or equal to 2 part, because that's a stricter, I guess I didn't need the greater than or equal part, I just needed the greater than. So we just use the x is greater than 2, and then we have to consider that the least common denominator would be negative, which would switch the inequality sign. So we'd get 6 is less than or equal to negative 4x plus 8. Subtract 8, divide by negative 4. We get x is less than or equal to 1/2. But we also have to consider that x minus 2 is less than 0, so x has to be less than 2. So it has to be less than or equal to 1/2 and less than 2. And x is less than or equal to 1/2 is the more restrictive one, so we have to go with that one. So now we know that x has to be less than or equal to 1/2, and from the previous positive case, we also know that x has to be greater than 2. So it's those two places on the graph where that would satisfy that inequality. All right, so good luck. Remember, there's another video to show how to do the second part of the worksheet or this part 2 of this assignment using the Desmos graphs. Thanks a lot and have a great day.